The objective is to identify, write, and graph a direct variation. I know we will at least get to identify and write a direct variation today. Here's the general form of a direct variation. Y equals kx, where k is a constant of variation. That means if I had y equals 3x, I could generate a table of values from that direct variation that will be consistent. So that if I put a 2 in for x, what value do I get back for y? If I put a 2 in for x, I get a 6 back, right? What if I put a 3 in, what do I get back? 9. If I put a 4 in, I'll get a 12. Put a 5 in, 15, 6, I'll get an 18. So that direct variation creates a table of values or ordered pairs that are consistent all the way through. In other words, you're doing the same thing to each x value each time to get to here. You're multiplying by 3. And if that's the case all the way through, you have a direct variation. So the following are items that are direct variations. If you have to identify one, then you should look at this list and know that these represent direct variations. Like we just did, y equals 3x. That's a direct variation. Y equals 1/3 x. That's a direct variation. If you have y equals x over 2, that is a direct variation. That's the same thing as saying y equals 1/2 x. Y equals negative 7x. That's a direct variation. But the following are not direct variations. These are not. Y equals 2x minus 1. If you have a constant at the end of it, or it could be before it, that's plus or minus something, that is not a direct variation. Y equals 5 over x. If you have an x on the bottom of a fraction, that's not direct. If you have xy equals 3, that's not a direct variation, because to get y by itself, you would have to divide 3 by x. That puts x on the bottom of a fraction. That's not direct. So here's an example. Solve for y and determine if the equation represents a direct variation. If so, then find k, the constant k, like from the very first thing we did. Y equals 3x. 3 was the k value. It's the constant. Well, if I'm going to get y by itself, then I need to move what's with it over to the right side. So that would give me negative 3x plus 6. So is this a direct variation? No, it has that constant plus 6 out there. This is constant of variation, negative 3. This is just a regular old constant out here. So the answer is no. Here's another one. Solve for y and determine if the equation represents a direct variation. If so, then find k. Well, if we want y by itself, then we're going to leave it here and the sign in front of it on the left. And put the 3x to the right, change that sign. To get y by itself, I would have to divide both sides by a negative 4. That means these negative 4's cancel out. And I have y equals double negative, so that becomes 3/4 x. Is this a direct variation? Yes. It is a direct variation. And what is k, the constant of variation? The general form is y equals kx. 3/4 is right. K equals 3/4. Here's another one. Solve for y and determine if the equation represents a direct variation. If so, then find k. What's the first thing I need to do in getting y by itself? What do I move first? Move the 2x. What happens to that 2x when I move it to the right? Negative. What do I do now to get y by itself? Yeah, divide both sides by 6. So when I do that, these 6's cancel out and I have y equals a negative 2 over 6x. Can I reduce that? What does negative 2 over 6 reduce to? Negative 2 over 6 reduces to positive 1/3. Negative 1/3, yes. Is this a direct variation? Yes. What is the constant k? Negative 1/3, yes. Here's another one. Solve for y and determine if the equation represents a direct variation. If so, then find k. So we have y equals negative 2x plus 3. Is this a direct variation? No. Solve for y and determine if the equation represents a direct variation. If so, then find k. If I'm going to solve for y, I'm going to keep the 4y on the left and move the 8x to the right. Change the sign. And then divide everything by 4. When I do that, these cancel out and I have y equals a negative 2x plus 3. Is this a direct variation? No. Let's get y by itself, so we'll have negative 2y on the left and negative 4x on the right. Divide both sides by negative 2, cancel, and come up with y equals 2x. So this is a direct variation, and k equals 2. Write an equation, determine if it is a direct variation. If so, then find k. Okay, so if you're plugging in x here, you're getting back these y's. Remember, a direct variation is y equals kx. So what's happening to these items here to get to y? To go from 1 to 3, am I multiplying by an integer to get from 1 to 3? If I multiply by 3 here, can I multiply 2 by 3 and get 5? No, so that's not what's going on. If I add 2 here to get 3, can I add 2 to 4 to get 5? No. So what may be going on is something where you multiply x by something and then add something to x. What can I multiply 1 by and then add something to that to get 3? Yeah, you're multiplying by 2 and then adding 1. So if I multiply this by 2 and add 1, can I multiply 2 by 2 and then add 1 to get 5? And 3 by 2, add 1 to get 7. 4 times 2 is 8, plus 1 is 9. 5 times 2 is 10, plus 1 is 11. Is this a direct variation? No, because it has this constant there at the end, so the answer is no. So that's the equation, y equals 2x plus 1, but the answer is no. It's not a direct variation. Okay, on this one, we're going from 2 to 6, and then 4 to 12, 6 to 18, 8 to 24, and 10 to 30. What is happening, if anything, each time that is the same to go from x to y? Yes, we're multiplying by 3. So y equals 3x. Is this a direct variation? Yes. And since it is a direct variation, what does k equal? 3. Write an equation. Determine if it is a direct variation. If so, then find k. Alright, so something is happening here, going from x to y. Is there an integer that I can multiply 3 by to get to 8? No. Can I multiply 3 by something and then add or subtract to get to it? What is it? Yeah, we're going to, well, let's see. Yeah, times 3 minus 1. Y equals 3x minus 1. 3 times 3 is 9. Minus 1 is 8. That would give us 15 minus 1. 21 minus 1, 27 minus 1, and 33 minus 1. Is this a direct variation? No. Write an equation, determine if it is a direct variation. If so, then find k. Well, we're going from x to y. What is happening to these x values to get to the y value? Am I subtracting 1 all the way through? Do what? Yeah, we're dividing by 2. So y equals x divided by 2. Or you can write it as y equals 1/2 x. Is that a direct variation? Yes. And what is k? One half. We're going from 3 to 8. You could multiply by 2 and then add 2. Would that work here? And there? Does it work all the way through? Is that a direct variation? No. And on this one, if I divide this by 2 and this one by 2, that would give me 4.5. This one by 3 would give me that, and by 3 and by 3. Oh no, this one by 3 would give me 2, yeah. If I divide by 3 all the way through here, I would get what I need. So that's the same as y equals 1/3 x. So the answer is yes, and k equals 1/3.